Example 2. Neglecting air resistance. The motion of an object moving vertically near Earth's surface is determined by acceleration due to gravity, which is approximately 9.8 meters per second squared, or A at t is negative 9.8. Suppose a stone is thrown vertically upward at t equals 0 with a velocity of 40 meters per second from the edge of the cliff that is 100 meters above the river. For this problem, the initial value problem is of the form the A at t equals negative 9.8. The A is the velocity prime or the v prime, and also the same as the s double prime as t equals negative 9.8. So we see this as a differential equation. With the initial conditions, the initial velocity or the velocity at the time 0 is 40. The unit is meter per second, and the initial position is 100 meters above the cliff, above the river. So S at 0 is 100, where V at 0 is 40, which is the same as S prime at 0. Part A, we find the velocity Vt of the object for t greater than or equal to 0. We use the differential equation of the form v prime at t equals negative 9.8 with the initial velocity v at 0 equals 40. Now we're going to find v at t, which is the antiderivative of negative 9.8 with respect to t, to get negative 9.8 multiplied by t plus c, or we use the term c1 from the first round of the antiderivative. As v at t equals negative 9.8 times t plus c1, we're going to find c1 using the condition v at 0 equals 40. Replace t with the 0, so negative 9.8 multiplied by 0 plus c1. So we get c1 equals 40. As c1 equals 40, we obtain the velocity v at t as negative 9.8 t plus 40. Next, we're going to find the position function s at t of the object for t greater than or equal to 0. From part A, we get the velocity function v at t equals negative 9.8 t plus 40, and v at t is s prime at t. So then the position st can be obtained by finding the antiderivative of negative 9.8 t plus 40 with respect to t. We get the position function st equals negative 9.8 times t to the second over 2 plus 40 times t plus c2 as a constant of integration, or the s at t equals negative 4.9 multiplied by t squared plus 40 times t plus c2. Next, we're going to find c2 using the initial condition. The initial position s at 0 equals 100. So the left-hand side, s at t equals 0 is 100 minus 4.9 multiplied by 0 squared plus 40 multiplied by 0 plus c2, or c2 equals 100. For c2 equals 100, we get the position function s at t as negative 4.9 t squared plus 40 times t plus 100. Next part, we are going to find the maximum height of the object above the ground, above the river, sorry. The maximum height, as you recall at the earlier of chapter 4, to find the local max, local min, we're gonna find the critical point or the critical value by finding the derivative and let it be 0. In some case, we have to consider the critical point from S prime undefined. For this case, the height as the position, find the local max of the height. So we're going to find the critical point from looking at S prime at t equals 0. And S prime at t is the velocity So we're gonna find the critical point of time t, where v at t equals 0. From part A, the velocity function is negative 9.8 times t plus 40. Now we let it be 0 and then solve for t. T is negative 40 divided by negative 9.8, and it comes out to be 4.08 seconds. So this is the time that the object will reach the maximum height. Now we're going to find the maximum height or the maximum position. So S at 4.08 is negative 4.9 multiplied by 4.08 squared plus 40 multiplied by 4.08 plus 100, and give us the maximum height is 181.63 meter. The next part, with what speed does the object strike the river? The key term speed. The speed is the absolute value of the velocity, and the velocity is the v. Now we're gonna use the condition that the object strike the river. Strike the river means the position is 0. The condition that the object strike the river, the s at t equals 0. So we're gonna work on solving for t, or find the point of time that the object reaches the river. As s of t is negative 4.9 t squared plus 40 t plus 100 equals 0, use the quadratic formula to find t. We get t equals negative 2.007 and t equals 10.17. We disregard the negative sign quantity because t has to be greater than or equal to 0. So then t equals 10.17 is the point of the time that the object will strike the river. So we use this point of time to find the speed. And the speed, which is the absolute value of the v, and the t is 10.17. So we find the absolute value of the velocity, which is negative 9.8 multiplied by 10.17 plus 40 in the absolute value to get the number as 59.67 unit is meter per second. So the speed of the object when it strikes the river is 59.67 meters per second.